Brilliant. Okay, I'm going to talk to you about AI scene analysis. I think we've established from Magnus's presentation that you all know what AI is, for sure, but how do you apply that to scene analysis? So, as an introduction, I'm James Varndell. I'm Senior Director of Product Management for Bitmovin Playback. So we create a video player product that runs on all devices. We also have analytics data that sits behind that as well. So firstly, what do I mean when I talk about scenes? Let's start there, given we all know what AI is now. So there's kind of two types of metadata when we look at content. There's asset level metadata. This describes typically an entire piece of content. It's top level information about the whole asset. So in this example here, which is a screen grab from BT Sport or TNT Sports app, content level metadata might be something like this match here, Man United versus Young Boys, for example. But then there's also scene level metadata, much more granular information about what's in the content and each of the scenes. So again, this example from TNT Sports, the timing of specific events like goals or yellow and red cards, for example. Sorry, James, can we swap? Yeah, okay, no worries. Can see feedback.
We'll cut this out the edit, don't worry.
Okay, hopefully this is all better now. All right, so asset level metadata and scene level metadata. So what we're looking to obtain is this scene level metadata, more granular information about our content. So how might we do that? And I want to talk a little bit about some work we've done in this area and some things that might help you out as well. So when we're looking at how do we extract scene level metadata using AI, one of the first questions is where should we run this AI from? And you'd be maybe interested to know that I do get a fair number of questions from people in the industry asking me, can we run an AI model on the video player side, which is kind of an interesting thing to consider. So on the right-hand side here, we've got a video player. This is in the context of Bitmovin's products, but applies to any kind of workflow. So if you run an AI model on the video player side, you could either send the content out or segments of it from the player to an AI model and get results back. Probably doesn't scale that well for every single video player. If you have 1 million users and each of them is making a request out to an AI model and sending content, that can be quite expensive, take up a lot of bandwidth, and there's probably some latency in doing that as well. You could potentially run an AI model on the device itself. Could work on some modern Apple devices, for example, but a super old 2017 smart TV that people still have in their homes might struggle with even playing back video or running your app. I'm sure those of you at FX Digital face those challenges all the time, as we do, let alone adding AI onto that device, that legacy device too. So what we've done is implemented our AI scene analysis within the encoding processes. So we have some input files. This could be output from a studio, for example, like a MXF or MP4 output. We're encoding that, and as part of the encoding process, the encoder actually can find shot boundaries and scenes within the content, and then we can send those downsampled to an AI engine and get results back. So we find that's actually one of the best places to implement this kind of AI analysis on content, because you have access to the content in a variety of different formats. If you wanted to send something super high bitrate, super high resolution, you probably have the original input files, or you could send a downsampled or encoded version, potentially with some scenes already extracted. And from that, we actually get back the output, and we put that together into a JSON, which lands on the output storage alongside the stream itself. So alongside the HLS or dash stream, we also have this JSON sidecar. We are working with some ad servers to potentially include that JSON within the actual manifest, like HLS or dash manifest itself. Once that JSON's there, it can then be used by the video player, and we'll see firstly what that output looks like and then how we might be able to use it. So what does the example output look like? So firstly, running the content and the scenes through an AI model, doing like a multimodal analysis. These are some of the things that we can get out. So we can get objects and characters, summary of what the scene is showing, potentially time of day, location, An interesting one, IAB taxonomies. I'm going to talk about that in a moment, and potentially like some sensitive topics or overall sentiment of a scene, which can be useful. I'll actually show you maybe a piece of content here. This is a demo that we have. So here's a scene. It's kind of a TV show set in Los Angeles, 1947. So you can see, yeah, it's kind of like a historic kind of TV show. So if we run through an AI analysis, like a multimodal analysis, we get this JSON output, and this sits alongside the stream, so the video player can access this information. So each of the scenes are described with a title. So there's potentially some like character recognition there, Los Angeles 1947 Street View, which was the title on the actual clip itself. Different things that were in the scene. I think we saw some vintage cars for sure within there. The setting, Los Angeles street, so we've picked that up quite nicely. And a set of keywords. And then interestingly, we have this section here, IAB, content taxonomy, ad opportunity taxonomy, and sensitive topic taxonomies. And this is a set of unique IDs which link into an IAB taxonomy database, which is available, it's publicly available on GitHub. They have a page here. There's multiple versions of this taxonomy, and same for advertising. So within here, you have all of these unique IDs and these references, and each of those describes some attribute of video content. So these are things that you might see in video, like outdoor activities, parks, for example, zoos, aquariums, and there's just a whole, this goes on and on and on. There's a whole load of keywords which are in here within this taxonomy, and there's a bit of hierarchy to it as well. So if we look at like automotives, so cars, there's different types of cars, hatchback versus off-road vehicles, for example. So this taxonomy is quite useful because it then allows us to take this scene analysis, describe it using a standard taxonomy that any system that knows about this IAB taxonomy will understand. So it reduces ambiguity. So if our output from our scene analysis says, okay, I've got something that's like ID 153 in there, that will tie into a keyword within this taxonomy, and it ensures consistency in the same word to describe the same thing. A good example might be if you think about UK versus, or English in the UK versus US, for example, we might say DIY, it might be termed home improvements in the US, same college and university, they're two different words that can mean the same thing in different countries. When we look at some of the use cases, if you then want to use that information, for example, to position an ad around some scene of somebody doing DIY, you want to make sure that you're using the same terminology as your ad server is using to describe the same thing. So this helps to standardize the terms you're using. That's what we saw. So now onto the use cases. I touched on advertising there. One of the use cases that we see is contextual advertising. So if you know this information about each scene that your AI analysis has output for you, you could use that to put an advert in the right context. These are some contextual advertising examples from other industries and sort of daily life, I suppose. So some nice ones, some Clear Channel here on like billboards. The one in the foreground is a sun care brand, or like a sun cream brand, and it says the UV level today is medium, so that's like live data, and they're using that to advertise sun cream. The one in the background is here in London, obviously not today because it's 30-something degrees outside, but instead when it was raining, maybe in the autumn or winter or something, the advert is from Heinz for tomato soup, and it's saying rainy rescue, so it's contextualizing their advert for soup with the current weather. People might want to go home and have a soup because they're cold and it's raining. We've all seen this type. This AI scene data is applied it to provide context to ad servers so that we can make advertising suggestions alongside specific scenes. So here we've got like an L-bar shape ad or an L-shaped ad around a scene of somebody riding on a motorcycle. So you can see the scene description. This is what we got back from our AI process and the AI model. It's saying that somebody's riding a motorcycle on a highway, they're wearing a helmet, maybe they're on a road trip, they're certainly outdoors. And the advertising suggestions there are maybe motorcycle helmets, outdoor adventure gear, accessories, adventures on the highway, like road trips, for example, as well. So if you can provide that information to an ad server, potentially you're going to get more contextually relevant ads, which can be useful for increasing your CPMs or giving viewers more relevant ads based on the actual content and the specific scenes they're watching. Interestingly, this can also work quite well in the reverse. So if you had, a classic example would be a plane crash scene, you probably don't want to have an ad for an airline in the ad break immediately after that. Probably wouldn't go down so well. So that can also work quite well too. But we think there are further use cases. These are some that we're working on and exploring. So improving recommendations and learn more overlays. The image in the top there is from Amazon Prime's X-ray feature, where if you like pause playback, you can see more information about the characters. This could be quite useful, like that previous example I showed of the TV show set in Los Angeles in 1947. Somebody might want to learn more about Los Angeles in 1947, and if you can provide that as a service alongside your video playback, it might be something that they use on your app or on your screen rather than opening their phone to look up, ask ChatGPT what's happening in Los Angeles in 1947. Secondly, optimizing ad placement. Particularly useful for fast channels, we think here, so recommending not just the context of the ad that I talked about, but also the best timing for ads. When does the scene end? So that could be a good point to insert an ad. But also you could combine that with user behaviors. We've done some research on that, which is the second screenshot you can see here, around when is the actual best place to position an ad when the viewer might be most engaged. And then thirdly, at the bottom, automated highlight creation, potentially custom timeline markers as well. So viewers could request custom highlights reels, highlights packages, like of their favorite player in a football match, or scenes they're most interested in. If they're watching Fast and Furious, how we chose to do it, how you might consider doing this as well. We've implemented this AI scene analysis within our encoding pipeline. It's available now. We've implemented the contextual advertising pipelines, also the automated ad positioning, which is good for fast channels as well. You can insert SCTV markers for those. And some future pipelines we have in the works, highlights and clips, like I mentioned. Also potentially combining this with like video QoE data or engagement data on the analytics side to understand how the content of a show or a movie is affecting viewer engagement or even quality of experiences. This is available, something you could sign up for and check out today. You can go to bitmovin.com, sign up for an account, and you can give it a try yourself. Happy to take any questions at this point.